Alright everybody, welcome to the notes and theorems video for rectangles and squares. These two shapes are two more parallelogram types that we have. In the last videos you probably watched, you saw about regular parallelograms that have a certain set of rules to them and how they work. And you saw rhombi, which are a little more specific type of parallelogram. They're ones that have sides that are all the same length. So now, we're going to round that out with two more types here. First one being a rectangle. And what a rectangle is it's a quadrilateral. More specifically, a parallelogram. With four congruent angles. Now, knowing that the angles in a quadrilateral always add up to 360 from our 8.1 notes, if all of the four angles are congruent, we just take our 360 and divide by 4, and we get 90. So we know that each of them are 90 degrees, which makes sense. You've, I believe, heard of rectangles before. I would hope so. And one of their properties is that they have four right angles. So that's good to know. Now, going back to these, a rectangle is always going to be a parallelogram. But a parallelogram will only sometimes be a rectangle. For example, if this were to be a parallelogram, that wouldn't be a rectangle. We can see that there are not four 90-degree angles in that shape. So it is a parallelogram, but not a rectangle. A little bit further information on rectangles. We'll know that a parallelogram is a rectangle if and only if, and this is a property that starts to become special for rectangles. It's different from rhombi. The diagonals bisect each other. So that is a pretty significant feature of the rectangle, and there's going to be another one that we talk about. So let's draw those diagonals in, and we know they're bisecting each other. Now, another thing that we know about rectangles that is not always true for your parallelograms is that the diagonals are also the same length. So that is kind of a nice feature that we have that we can use, which is just simply not always true for your parallelograms. So they not only bisect each other, but they are also equal to each other. Okay, so that's rectangle. Square is like the combination of a rhombus and a rectangle. A square, actually that's what I have right here, so I'll write that in right now. So it's a rectangle and a rhombus, which means that it's a parallelogram with two big features. One, equal side lengths. And two, four 90-degree angles. So, if we wanted to make a little bit of a Venn diagram to describe this, we have this box here, and this box could represent all parallelograms. Everything in this box would be a parallelogram shape. And outside of the box, we could say that we have quadrilaterals in general. So within quadrilaterals, there's a specific box here called parallelograms. And within parallelograms, we have these divisions that are rectangles. And rhombi. And then the combination of those two, where they overlap, that's our group of squares. So it's like this family tree of quadrilaterals that we're forming here. Thing to keep in mind is all of these shapes that we discussed in these two videos so far, the rhombus, the rectangle, the square, and the parallelogram, they all follow the rules of the parallelogram, but the rhombus, the rectangle, and the square have extra things that they also help us see, which help us solve problems for them a little more easily. So just keep that in mind as you're looking at problems that involve these shapes. Remember, the square will have all of the properties of the parallelogram, the rhombus, and the rectangle. And that's how we get all the properties of the square. So everything you've seen so far will apply for the square. Thanks for watching this one. I'll be back with the examples video very soon. See you then.